polar coordinates. Polar coordinates are the most natural coordinates. It's the most natural way how you're going to give direction. When I'm giving direction, I am giving two pieces of information. Which way to go, and how long to go this way in distance. So let's pretend we are on xy plane. And we are standing at the origin. And we need to give a direction how to get from origin to point A, located somewhere on that xy plane. So I need to give a direction how to, from origin to get toward point A. And my direction is going to be given by angle theta, which is angle between straight line from origin to point A and positive part of x-axis. And also I'm going to measure the distance between origin and point. And distance, we're going to be using letter r. So polar coordinates is going to consist of pair distance, which is how long, and angle, which is direction, theta. So polar coordinates consist of pair r and theta. Now if you look at that triangle, the right triangle which we have right here, I'll copy it. That's a right triangle. Hypotenuse r, vertical is y, horizontal is x, angle is theta. So we can solve this triangle and find that cosine theta equals to adjacent over hypotenuse, sine theta equals opposite over hypotenuse, and tangent theta equals to opposite over adjacent. So cosine theta equals to x over r, sine theta equals to y over r, tangent theta equals to y over x, and recall Pythagorean theorem, which will tell us r squared equals to x squared plus y squared in this case. Hypotenuse equals to x squared plus x squared. So from here we're going to get few main identities which we're going to be using for polar coordinates. From the first one, cosine theta equals x over r, we can get that x equals to r cosine theta. From the second equation, we have sine theta equals y over r, multiply both sides by r, we're going to get y equals to r sine theta. And we copy two more. How to find angle, tangent theta equals to y over x, and r squared equals to x squared plus y squared. Those are our main four equations which will relate polar coordinates r and theta with rectangular coordinates x and y over point. From polar to rectangular. If we have point given to us in polar coordinates as 3 and pi over 3, so in this case we have r equals to 3 and theta equals to pi over 3. And we want to find in rectangular coordinates of a point, so we want to find x and y. So to convert from polar to rectangular, we're going to rely on formulas that x equals to r cosine theta, y equals to r sine theta. If we know what r and theta is, we should be able to get x and y coordinates of a point by plugging in correspondingly r and theta. So in this case, we're going to get x equals to 3 cosine pi over 3, y equals to 3 sine of pi over 3, finish up the calculations. Recall that cosine of pi over 3 is 1/2. So we're going to get 3/2. And recall that sine of pi over 3 is root of 3 over 2. So we're going to get 3 root of 3 over 2. So rectangular coordinate of a point is going to be 3/2 is x coordinate and 3 root 3 over 2 is y coordinate. So that is answer for part A. Part B. Say we have polar coordinate of a point given to us by r equals to 2 and theta equals 5 pi over 6. Again, we're going to be using these two formulas. X equals to r cosine theta, y equals to r sine theta. So we can go into get x equals to 2 cosine of pi 5 pi over 6, y equals to 2 sine 5 pi over 6. So we're going to get 2 times negative square root of 3 over 2. So we're going to get negative root of 3. And we're going to get for y 2 times 1/2. And we're going to get 1. So for part B, our answer in rectangular coordinate of a point will be x coordinate is negative root of 3. And y coordinate is going to be 1. So if point is given to us in polar coordinates, then we're going to use x equals to r cosine theta, y equals to r sine theta to switch to rectangular coordinates. In the next example, we want to convert from rectangular coordinates to a point to polar. When we're going to be doing that, we're going to rely on two formulas that r squared equals to x squared plus y squared. So that formula tells us how to find r. So r we're going to be square root of x squared plus y squared. And tangent theta is going to be equal to y over x. So to find theta, we're going to take tangent inverse of both sides. The only catch is because range of tangent inverse is going to be from here to here. So range of tangent theta is between negative pi over 2 and pi over 2. So if an angle is located in quadrant 1 and 4, when here to find theta we're going to be doing theta equals to tangent inverse of y over x. When we are located in quadrant 2 and 3, we still want to do tangent inverse of y over x. The only catch is we want to move to quadrant 2 and 3, and what we do is we'll say theta equals to tangent inverse of y over x, and we're going to put extra pi to it. And that's what we'll do if where angle is going to, if a point is located in quadrant 2 and 3. Okay, keeping that in mind, let's do a couple of examples how to find coordinates of a point in polar coordinates. If point is given to us in rectangular is 1 and 1, so in this case x equals to 1 and y equals to 1, so we can easily find r squared equals to 1 squared plus 1 squared equals to 2. So r equals to root of 2. Tangent theta equals to 1 over 1, y over x, so equals to 1. Visualize the point. Point with coordinates 1 and 1 is located in quadrant 1, therefore theta equals to tangent inverse of 1, so it equals to pi over 4. So polar coordinates of a point are going to be r equals to root of 2 and angle equals to pi over 4. If we have point given to us in rectangular coordinates as negative 3 and 2, then r squared is going to be negative 3 squared plus 2 squared is going to be 9 plus 4. It's going to be 13. So r equals to square root of 13. Now to find theta, firstly we find tangent theta. Tangent theta is going to be y over x. Y is 2, x is negative 3. So tangent theta equals to negative 2/3. Now let's visualize where a point is located. Point is located in quadrant 2. X equals negative 3, y equals to 2. So quadrant 2. So theta is going to be tangent inverse of negative 2/3 plus pi. Because again, range of tangent inverse is between negative pi over 2 and pi over 2. To get to quadrant 2 and 3, we need to add extra pi. So theta equals tangent inverse of negative 2 over 3 plus pi. We use a calculator to approximate that expression, so it's 2.554. So the answer for this problem is polar coordinates are going to be r equals to square root of 13 and angle equals to 2.554. Comment on polar coordinates. If we have point given to us in polar as r and theta, because x and y are given as r cosine theta, r sine theta, and cosine and sine will have a period of 2 pi, but immediately from here we notice that point which we're going to have coordinates when we have an extra full rotation to the direction, it's going to be exactly the same point. Or extra 2 rotations, theta plus 4 pi, it's going to be exactly the same point. So in general, if we add 2 pi n full n rotation to a direction, it's still going to be the same point. That's the first comment. So all these points are going to be exactly the same. So if you say angle pi or 3 pi or 5 pi, that's the same direction. So if we have angle theta, or if we have angle theta plus 2 pi, it's still the same angle. So that's why all these points are exactly the same. That's the first comment. Second comment which I want to make is, if we have, usually r is positive, but sometimes it will happen that r is negative. So what is happening when we have negative r? When you have negative r, that basically means instead of going into the positive direction along the direction given to us by angle theta, so instead of going this way, we're going to be going this way, so it's negative r. So that kind of tells us that if we want to still have the same point with coordinates r and theta, then we'll do the following. We, instead of picking the direction theta, we pick direction of theta plus pi, and in that direction, theta plus pi, we're going to measure negative r. So you flip the direction to the opposite side and you get negative r. So negative r and theta plus pi are going to be the same point as r and theta, because 5 plus beta, 5 plus pi, 5 plus pi will tell you that you switch direction. Negative r also will tell you a switch direction. You switch direction twice, we're going to get to the same direction, original direction. Let me try to illustrate that on an example. If we have point given to us in polar coordinates 3 and pi over 4, and we want to find few more its polar coordinates, the easiest thing to do is take 3 and keep an angle with extra rotation. So we're going to get 3 4, 9 pi over 4. Another possibility is we switch r into negative 3, switch it r to negative 3. So we switch in direction into opposite, and we switch it once, and by adding pi we switch in second time. So we switch r, and we say in r, instead of going this way, we switch to opposite direction. And we're doing the same with theta. We say instead of going this way, we're switching it to extra pi, switching to opposite direction. We switch direction twice. Put in minus and put in extra pi. So it's the same point. So we have negative 3 and 5 pi over 4. So those are two extra ones, and you can